Welcome back students to physics online class. My name is Parth Davda. So I am here to explain you the four major concepts of physics about motion and some numericals. So let's get begin with it. The very first thing is what are we going to study? We will be looking at distance, displacement, speed, velocity, acceleration, formula for converting kilometer per hour into meter per second, since this was one of the major issues, numericals which I'll be showing you, and then I'll be giving you 10 numericals for your practice. So let's begin with the very first thing. So this shortest distance between A to B is referred as displacement, and this particular place A to C and this whole path is referred as distance. Distance will be a scalar quantity, whereas displacement will be a vector quantity. We'll be looking at this particular thing in a while. So in this figure there can be various paths as we have discussed, but the shortest path, which is this one, denotes the actual change in position from initial point A to the final point B, which is known as the displacement. So here is the difference between distance and displacement. It is very important to understand this, because this concept will be coming in the next chapter as well. The actual path covered during the motion of a body is called distance. If you are traveling from anywhere to any other place, well, that is the distance. Even if you are taking just 1 foot ahead, that is distance that you are traveling. On the other side, the change in the position made during motion of a body is known as displacement. So when you are changing the position, which means that if your starting point and the ending point is different, then there will be some non-zero displacement. But if your starting and the final point is same, then that will be considered as zero displacement. So distance can not be zero, whereas displacement can be zero. I hope so far is so good. Moving ahead, in distance, it is needed not to be the shortest path between 2 points, as we have discussed it earlier in the previous slide. Displacement is the shortest path between initial and final position. And that brings us to the last point about it. Distance is a scalar quantity, as it does not have any particular direction. When I am saying I traveled 50 kilometers, it may be in any direction. It may be going to a place, coming back. It may be going to a place A, traveling to place B, and then again coming back to place A. Well, displacement, it is a vector quantity, as it is always directed. Whenever I am saying that I have traveled 50 kilometers towards north, now see, I have got one direction that I am traveling towards north, so that will be referred as displacement. If I say 30 kilometers south, or 20 meters east, or 10 meters west, these all are the examples of displacement, because we have a direction in it. Alright, I hope the distance and displacement is completely clear. Well, then we shall proceed further to the next topic, that is speed. Now students, you have been studying speed since grade 7, and you have been understanding speed since when you are not even knowing the spelling of speed. When somebody is throwing a ball at you when you are younger, with how much speed is it coming, how much distance is it away from you, and in how much time will you be able to catch the ball, you are calculating all these things without actually calculating it in terms of a numerical or a sum. So speed is a topic which you have been learning since a long time. Now speed of a body is the distance traveled by the body in the unit time, and hence we are having the formula something as this: speed equals to distance upon time. The SI unit of speed, means the standard unit of speed, is meter per second, and this is how you will be writing meter per second. Since distance is measured in meters and time is measured in seconds, so we refer as meter per seconds. Now speed has only magnitude. Magnitude meaning that if I am saying 10 meter per second, then it is having just the magnitude. It does not have any sort of directions. So this is referred as only the magnitude, and hence it is known as scalar quantity. I hope the topic is clear. It's pretty easy one. So we move ahead with the next one, that is velocity. Now speed and velocity is one of the greatest confusions of physics, since they are connected very very closely. In speed we were having distance upon time, whereas here it is the displacement upon time. Now as we have discussed earlier, distance was scalar, displacement was vector. So in velocity displacement is there, hence velocity will be a vector quantity. It is having magnitude as well as direction. So if I want to say that I travel 10 meter east in 2 seconds, well then that's how we will be able to calculate velocity, where the 10 meters will be our displacement divided by time, which was 2 seconds as an example, and which will give us the answer as 5 meter per second. Okay, so we move ahead with the next thing, and let me just finish writing this. It will be 5 meter per second. Now velocity of a body is displacement of the body per unit time. This is the definition of the whole term velocity. So moving further, I hope I am clear till now. Speed is scalar quantity because it has distance, and velocity is vector quantity because it has displacement in it. The formula is pretty much similar. You just have to replace the distance with displacement. Otherwise time is also present, same, and the word velocity is again replaced by speed. So that was the second most important thing. Coming on to the next topic, that is acceleration. Now when you are whenever we are saying that we are moving from 0 to 100 km/h speed in 10 seconds, well then there is a change in velocity from 0 to 100, and that's what is known as the acceleration, from 0 to 100 in some unit time. So that's how we will be defining it. The quantity which specifies the change in velocity is acceleration. It is the change in velocity of a body per unit time. This is its definition. So acceleration will be written in the form of the formula as change in velocity in the unit time. So let us specify, if the velocity of a body changes from initial velocity u, we will be defining initial velocity as u and final value or final velocity as v. In time t, a body is undergoing a change of initial velocity u to a final velocity v in time t. Then the acceleration will be the acceleration a will be referred as a equals to v minus u upon t. What does it mean? Final velocity minus initial velocity upon time taken. This is what it means. The example which we took from 0 to 100 in 5 seconds, well, in 0 to 100 in 5 seconds, we will be able to, we just have to put it, our V final value was 100. We started our journey from rest, so that was 0. So how will we put it? We will be putting it as 100 over here minus 0 over here upon time, which was 5 seconds. So that will be put over this place. So 100 upon 5 will be giving us 20. So 20 will be my answer, will be my acceleration, 20 meter per second square. So that's what is the acceleration. Since velocity will be in meters, meter per second, and acceleration will be in second, so we are getting this unit as meter per second square. Proceeding further with the next topic. See, this is everything basic. So formula for converting kilometer per hour into meter per second. Now this is used widely when you are performing any numericals in motion as well as in the laws of motion, which is the next chapter. It is extremely simple. When you want to convert from kilometer per hour into meter per second, you just have to multiply by 10 upon 36. So it is very simple procedure. You just have to multiply with 10 upon 36. Easiest one. So let us have a look at some numericals about it. Very first one, I want to convert 18 km per hour. I want to convert 18 km per hour into meter per second. So let us take 18 km per hour into into 10 upon 36, and this will when we will be just solving it, 18 times 1 and 18 times 2, we shall be getting 10 upon 2. Further cancelling it, 1 and 2 times 5. So with this we will be getting it 5 meter per second. Very easy to understand. It's just merely multiplying 10 upon 36. You can also take 5 upon 18. It is same. Let us have a look at the second example. 72 km per hour. I want to convert it into meter per second. So again, multiplying it with 10 upon 36. Same procedure. 36 times 1, 36 times 2, and yes, you guessed it right, 2 times 10 will be 20 meter per second. I hope it is quite simple. Where we will be using it? We will be using it in the coming numericals, where the numericals will be consisting of acceleration and many more other things. This will be just a small part of it to convert into the standard units. So please do this conversions, and if you are having any doubts, then do let me know related to this. Now we shall be going further in detail about the acceleration. So let's get started. Now recalling various units, the very first unit is distance and displacement. That is measured in meters, and the symbol is m, small m. The next is velocity and speed. Both are having meter per second as their standard units. Then the acceleration, the thing which we are based on, meter per second square, and this is how you can write meter per second square. And time, this is something which you might be already aware of, which is seconds. Understanding the acceleration equation. Now if the velocity of a body changes from initial value, that is shown by u, to final value, which is shown by v, in time t, then the acceleration a can be written as a equals to v, that means final velocity, u, that is initial velocity, upon the time taken. Initial velocity is u, final velocity is denoted by v, time is t, and acceleration is a. And this is what the formula is: final velocity minus the initial velocity upon the time taken, which gives us acceleration. And acceleration will be measured in meter per second square. So we proceed further with the next thing. The very first thing, numerical number 1. A bike is traveling at 36 km per hour. It speeds up to 72 km per hour in 2 seconds. So here what things you need to understand: a bike is traveling at 36 km per hour. That means its initial velocity is 36 km per hour. Okay. Now it speeds up to 72 km per hour. That means the person is increasing the speed to this value, that is 72 km per hour. So it is reaching to this 72 km per hour. So that will be our final velocity, and time taken is 2 seconds. You have to find acceleration. Now always remember in physics that you need to first of all grasp the data, first of all absorb the data, and then you can begin with it. So very first thing, u equals to 36 km per hour, v equals to 72 km per hour, and time taken is 2 seconds. This is known as the absorbing of data. The very next step, before you calculate anything, will be converting into the standard units. Now students, have a look at this. This is in kilometer per hour, and this also is in kilometer per hour. And now you are knowing the conversion, how to convert it into meter per second. And since meter per second is the standard unit, we need to convert it into meter per second. So when we convert u into meter per second, we get 10 meter per second. And v equals to 72 km per hour converted into meter per second will be 20. Time is already in the standard units, so no need to convert it as of now. It is 2 seconds. So the formula is a equals to v minus u upon t. We will substitute the values that we are having, that is 20 minus 10 upon 2. Remember always to put the final velocity first and then the initial velocity. So stick to this formula of v minus u upon t. And time taken is 2 seconds. Simple calculation, simple math. 10 divided by 2, and you'll be getting the answer as 5 meter per second square. The unit is very, very important in every single numerical of physics. So remember to put the relevant unit at the end of each answer, each calculation that you perform. I hope this is clear. Alright, so we proceed further with the next numerical. A car is traveling at a speed of 108 km per hour. When the brakes are applied, it stops in 5 seconds. What will be its acceleration during this time? Now understand one thing very clearly. It is already moving at 108 km per hour. So our u, initial velocity, will be 108 km per hour. When the brakes are applied, and it stops in 5 seconds. So when the brakes are applied, ultimately it will be reaching to a stagnant position, to a rest position, and hence our v equals to 0 km per hour. and the time given is 5 seconds. Now converting all of them into its standard units. So u will be 30 meter per second, okay. V will be 0, as anyway it is 0, and time is already given into the standard form, that is 5 seconds. I hope you are able to understand this. Initial velocity 30 meter per second, final velocity 0 meter per second, and time taken for this whole change is 5 seconds. Now you need to understand one thing, that the brakes are applied, so it is coming to rest. So let us put into the equation. A equals to V minus U upon T. Now pay attention over here very carefully. You are not supposed to put a bigger number at first position. You have to stick to the formula. You have to use the V, the value of V, which is 0, and value of U, which is 30, as provided earlier. The time taken was 5 seconds, so that is the thing. 0 minus 30 will be minus 30. Be very careful with this, because negative and positive, the sign can make a lot of difference. So minus 30 upon 5, well, you would have guessed it by now, will be minus 6 meter per second square. Now this negative sign which you are able to see over here, that negative sign proves that the brakes were applied. So acceleration can be in negative. When the brakes are applied, any object which is moving will be reducing its speed, hence your V will be lesser than U. So this negative sign will appear in the answer, and that is completely normal. Now if at all you had put anything else, say for example if you have taken 30 minus 0 upon 5, then you would be getting the answer as positive 6, which would be wrong. So I hope you are clear with the reason why this negative sign is so much important for us. So we proceed further. Next numerical. A jet aircraft starting from rest attains, means it reaches, a velocity of 540 km per hour in 5 minutes. Calculate its acceleration. Now a jet aircraft is beginning its journey from a rest position, which is very, very important for us to understand. If it is beginning from rest position, that means what will be your initial velocity? Your initial velocity will be 0. It is attaining a velocity of 540 km per hour, so your final velocity will be 540 kilometer per hour. Proceeding further, time is given 5 minutes. Now 5 minutes is again not converted into its, not given into its standard unit, so we will be converting it into the standard units. First of all, u equals to 0 meter per second, converting it. V equals to 150 meter per second after conversion, and 5 minutes equals to 300 seconds. So this is the very first step, grasping the data, and the very second step is the conversion into the standard units. Once these things are clear, then and then only we have to proceed further. So let us move ahead, substituting the values into the formula of A equals to V minus U upon T. That will be 150 minus 0 upon 300, which is 150 upon 300, and at the end acceleration will be 0 meter per second square. I hope the things are clear till here. Okay, so then we proceed further. Now students, this particular type of numerical is based on the graph. You will be provided a velocity versus time graph. This is over here, you are having the velocity. Over here, you are having the time. Okay. So, what is the question that is asked? The question is that calculate the acceleration from A to B. This is the point A, this place, and here is your point B. Okay. Fine. Then so let us obtain the data. Over here, what will be our u? Our initial velocity will be 0 because it is beginning from the rest, as you can see. So our u will be 0 meter per second. Then B, at point B, your final velocity. What is the final velocity related to it? You can see it over here very clearly. That is 25 meter per second. So that is the second value. Now finding the time, because we require in the formula how much time it took from A to B. Have a look at it. From A to B, beginning from this place to this place, it is how many seconds? 3 seconds. So I hope the grasping of data is easier in graph method. I'm just repeating myself. Calculate the acceleration from point A to B. So from A to B, your initial velocity is 0 meter per second. Your final velocity is 25 meter per second. And time taken during this time, as you can see, is 3 seconds. I hope it's clear. Alright. So putting it into the formula, V was 25, U was 0. So 25 minus 0 divided by 3, which will give us 25 divided by 3. And when you will perform the calculation, it will give you 8.33 meter per second square. You have to go only maximum till 2 decimal digits. Numerical number 1. If an object moves from point A to point B and then to C and returns to point B, calculate the distance and displacement. Well, this is extremely easy and a very basic level of numerical, where the distance between A to B is 40 meters, B to C is 30 meters, and the object is moving from A to B and then from B to C, and it is returning to point B. I hope the question is clear. Okay, so what will be the distance traveled during this whole journey? It is extremely simple. The distance traveled between A to B and B to C is 40 plus 30, so that will be 70 meters. But the person is traveling from C to B as well, so another 30 meters will be added, as the direction will be from C towards B at the end. Hence, the answer will be 100 meters. I hope the thing is clear. Okay. Now coming on to displacement. How much will be the displacement? Now the shortest path between the initial position A and the final position, which was B, will be, you guessed it, right, that will be 40 meters. So the net displacement is 40 meters in this case. Quite easy to understand. Okay, so we proceed further. Next numerical. Now this numerical, I would like you to solve it on your own. Same numerical, same type of numerical, where the values are changed. If an object moves from point A to point B to C and returns to point B, calculate the distance and displacement. So A to B is 50 meters, B to C is 20 meters. The object is moving from A to B, B to C, and then returning to B. I hope you have solved it by now, because the numbers are extremely easy to add up. So your distance will be 50 plus 20 plus another 20 from C to B, and the net distance that you will be getting is 90 meters. What will be the displacement? I shall give you 10 seconds of time to type your answers. Well, the displacement will be 50 meters. That is the correct answer. Okay, so we proceed further. Numerical 3. A person moves 6 meters east, takes a right turn, and walks for another 8 meters. How far has he traveled? And how far is he from the rest position or from the initial position? So let us begin with it. 6 meters towards east, then takes a right turn, so 8 meters towards the right turn from there. How far has he traveled? That means that is basically nothing but the distance traveled by the object. So how far has he traveled from this to this motion? The distance will be 6 plus 8 meters, which gives us 14 meters. Extremely simple to understand. Okay, so we proceed further. How far is he from the rest position or the initial position? So for finding the displacement, we need to apply the Pythagoras theorem. A to B 6 meters, B to C 8 meters, and the shortest distance between A to C will be found by applying Pythagoras theorem, which is AC square equals to BC square plus AB square. So substituting the values, and we get 64 plus 36. So AC square equals to 100 and AC equals to 10 meters. So hence our displacement is 10 meters. I hope it is very clear. Numerical number 4. An athlete completes one round of a circular track of diameter 200 meters in 40 seconds. What will be the distance covered and displacement at the end of 2 minutes 20 seconds? Now this numerical is from the textbook, question number 1 of your exercise, chapter number 8. So let us begin solving this numerical. The diameter of our circular track is 200 meters. Radius of the track will be half of it, so that will be 100 meters. The circumference, that is the perimeter of the circle, is referred as 2 pi r, and over here the value of r will be 100 meters. So as you can see, so we are having the answer as 2 pi into 100 as 200 pi meter. In 40 seconds, the athlete is covering a distance of 200 pi meters, right? That's what we just discovered. Okay. So in 1 second, the given athlete covers a distance of 200 pi upon 40. And the athlete runs for 2 meters 20 seconds. That means when we convert it, it will be 140 seconds. So putting all together in one equation, the total distance covered will be in 140 seconds will be 200 into pi. So that will be 22 upon 7. upon 40, because one round is taking 40 seconds to complete, and the whole thing will be multiplied by 140 because that is what the total time with us is. So when you solve the equation, you get 2200 meters. This was the distance that is traveled. So let us talk about the displacement. Now the displacement present will be based on the athlete covers one round of the circular track in 40 seconds, as mentioned earlier. This means that after every 40 seconds, the athlete comes back to its original position. Okay? Hence, in 140 seconds, he had completed 3 rounds of the circular track and is taking the 4th round. So suppose if it is taking, he takes 3 rounds in 40 seconds, so that will be total time will be 120 seconds is already elapsed, already consumed. So we are left with, from 140 seconds, we have finished already 120 seconds. So we are left with 20 seconds as the time. So whatever is the displacement taking place is taking place in that 20 seconds. So after 120 seconds, his displacement is 0. Since the displacement is equal to the shortest distance between the initial and the final position of the athlete, so the displacement of the athlete will be equal to its diameter of the circular track, which is from point A over here to point B, directly along this particular path. So how much will be the net displacement? The net displacement will be 200 meters, since A to B is this one is the shortest path. I hope this particular concept is clear. So that's the end of session 1. Derivation and numerical of equation of motion will be taken in the next session. Thank you.